Okay, so this is the second version of my promotional video for my package FeedIM extensions configuration protected. Because the first one I was speaking too fast, and I'm quite fast speaker, and sometimes I mumbled some words, so I want to create another video. I tried at my best to speak as much slow and fluent as possible. So this package, the idea started on October 23, where when I released another NuGet package, which is now obsolete and deprecated, which is protected JSON, which was basically custom configuration sources, which allow it to encrypt and decrypt configuration keys inside only JSON files. FeedIM extension configuration protected is instead the extension of that package to all configuration sources. So you can encrypt, decrypt JSON files, XML files, environment variables, command line arguments, and whatever else also in the future. To understand what the package does, I have here a simple console test program, which is included in the GitHub sources. And but before starting, I want to explain what is a configuration builder. Configuration builder is a class, standard class of the net and net core framework, which allows you to add one or more configuration sources. In every method you call after the new configuration builder is a configuration source. In this way, we can see we add a command line configuration source. We add here two JSON files configuration sources, one XML file configuration source, one in-memory collection configuration source, which is basically a dictionary, and an environment variables configuration source. FeedIM configuration protected allows you to just simply replace the call from new configuration builder with new protected configuration builder, passing some information about what encryption method to use and what tokens you have to use to extract the data to be encrypted and decrypted. And then you can use all the standard network provider configuration sources, and you'll be able to encrypt and decrypt all them flawlessly. Okay, let's start. So hit F5. Okay, I want no, I'll just start again. I want to put a breakpoint here before encrypting the things. So basically, with this simple console application, it has a command line, array of string arguments. Is this one? I hard-coded it here, and then we have a dictionary, and this is called the net framework calls it in memory collection, but it's basically dictionary or string. And then we have some environment variables. Now here we encrypt all these configuration sources with these methods provided by the standard class used to encrypt everything. It is this class here. It is data operation API protect configuration data. To create it, basically, one thing. This package is pluggable, so you can use different encryption methods. I started by using the Microsoft one. Then some comments came below and asked for more flexibility. So I implemented some interface which allowed you to make the decryption algorithms pluggable. So there is the base package, which is the fidelity configuration protected, which performs the decryption calling external providers. And then we have a standard provider based on the Microsoft Data Protection API, which is this one, fidelity extension configuration protected data protection API. I'm using here, since this is now the only one, I'm testing here the one with the data protection API. Basically, you have to configure the data protection. The data protection is configured in the standard Microsoft way. So we have here a method, add data protection, which is basically, sorry, this one, configure data protection, which is basically setting up the encryption algorithm. Yes, 256 CBC, and also validation algorithm, the digital signing algorithm. And it says also where how long the keys are valid and where to persist them. This is all standard Microsoft Data Protection API. And basically, you configure basically dependency injection. Here you configure a bit service provider. And with this provider, then you create a data protection API protect configuration data. What does basically contains this class besides the decryption provider? Well, this class derives from this interface, which basically has four key values. The first one, the product provider. It's the decryption, the interface for the decryption pluggable provider. This interface is very simple. He has one method to encrypt, one method to decrypt, and one method to create a derived provider from a sub key. This is a feature of the data protection API, which allows you to derive different encryption keys starting from one master key using by one or more subports for strings. It's optional. If you want, you can return just this, you return the same, but it's another plus. Anyway, the three other parameters are basically the way to regex, so regular expressions, which tells the engine what is the data you need to encrypt and what is the data you need to decrypt. And then there is also a string which allows you to transform an unencrypted string in an encrypted string. Let's see for some examples. Let's go, for example, on an appsettings.json files. Okay, this is a plain file, unencrypted, but you can see here that we have on this key, configuration key, encrypted JSON special characters, a tokenization, which is protect colon open parentheses something to encrypt close parentheses, and we see it again here. For example, in the connection strings, we have free connection strings. We have the plain text connection string. We have a fully encrypted connection string because there is just one protect token which encrypts all the whole connection string. But we can also have another feature which is of partial encryption of the configuration value. So you can enter as many protect colon open parentheses what you want to encrypt, close parentheses, inside the string, as many as you wish. Here you have 4 different ones. The code will fetch all of them and decrypt all of them automatically. And basically, this organization protect colon parentheses, what to encrypt close parentheses, has been decided by me, but it's not fixed. You can change it to whatever you want. The only contract is that all regular expressions have to extract all the data which needs to be encrypted in a particular named groups. If you don't know what are regular expressions, they are used basically for parsing and for tokenization. So you have a big string and you want to split different pieces of the string and then extract some data which you need to parse. And the regular expression are very handy and good to do that. There is also mathematical theory, but essentially there is just a string. You can see just one. Let's go back to the interface. This one. Okay, here we have the default regex strings, which are provided by the NuGet package. This is the protect regex string. Basically, you define a named group in this way. You enclose what you want to assign a label inside 2 parentheses, round parentheses, and then you this one, and you make come before them this this syntax. So question mark minor the name of the named group you want, so the label you want to assign, and measure. In this case, the one we are talking is protect data. So the subpurpose part and subpurpose are used for subpurpose for the deriving a subkey. They are optional. But what's the most important one is the one this. So in the protect regex strings, you must have at least a named group called protect data, and the code will extract all the information from this named group and it will encrypt it. For decrypting, you have to have a regex with a named group called protected data, and the code will extract all the tags matching this regex and decrypt all the protected data the values inside. Then there is the protect replace string, which basically is used to convert a protect expression into an encrypted expression after it has been encrypted into an encrypted one. You can use the same. There is no problem, but I want to make them separate, so you have the most flexibility. So summing up, this class tells you 2 regex, one string to transform one regex into another, and the encryption provider, the pluggable encryption provider. Let's go back to the main code. Okay. Here I'm setting up different encryption providers, different protocol configuration data, because, for example, here is the standard one. This one is for example, another feature is the custom tokenization. I did not like the protect and protected. I want to use another tag because I want to use another tag. And boom, you have here. There is other protect. We will see then in example file, and other protected. It's a very simple example, but it's very flexible. You can choose whatever you want. And here I'm using a derived encryption provider from the standard one. So basically, it's using a derived subkey to encrypt the data. Then we have this keyword which is used to tell only to the protect function that you are dealing with JSON with comments. This is a problem on the net framework. At the beginning, the classes to load JSON files allowed the comments, and then the manager decided to forbid them because according to the standard, there should be no comments inside JSON files. The code was working perfectly. You had an option which allowed you to configure it, but now every time you configure this option, it throws an exception, the Microsoft code. Maybe, if I remember correctly, because it's passed almost a year since let me see. Just a second. It's a comment, but I have to remember. So let's go to the code and see. We have to go to the JSON file protector, which is this one. Okay. I have installed a comment in the source code, systemcore 3.1. JSON comment ending .allow always raise an exception. If you guys also a link to the source code, I don't know if it's still working. Let's see. Yes, it's working. You see that when you set it, its search value is more than 10, but if the value is more than skip, and skip, if I remember correctly, is the second one, so allow is the third one, it throws argument over range exception and says JSON document does not support the comments, the error. But the code here actually did support it, and it has been removed. Anyway, maybe it will be interesting to use it. So let's go back. Anyway, this is just a clause that you are using. You want to encrypt JSON files with comments, which is not standard. Usually, JSON files for the standard can't have comments. Okay, here this is the first method. We are passing the args. The args is this one, which is the watch window. Okay, is here. I don't know why. Okay, I like this. So let's see, args are this one. Now executing this code, you will see that all these things, which is encrypted inside the protect tag, it will be encrypted. It throws a new array. It does not encrypt the existing the in-place array. Okay, we have here that the protect tag has been transformed into a protected tag, and they have here a base64 string. This is because encryption deals with binary data, and binary data you can put the binary data inside a string. You have to perform some encoding, and the most famous and the most widespread is the base64. Then we have we can do the same with the in-memory dictionary. If I remember correctly, this encrypts the dictionary in place. So they will encrypt let me see, also this, because not all entries, okay, also this not, also this. Okay, let me see if I can go a little further. Boom, you see that they become red become red, and they have been encrypted. Now we want to script we use the product files. This method protected a configuration value which is an array, which method protected a configuration value which was also overloaded with the dictionary. This method instead product files. It scans for concurrent files. It is configurable. I mean, you can say, for example, by default, it has the pattern star.json. You can say on top directory or subdirectories. You can also ask to backup the original file or not. And it will return you the list of the files which have been encrypted. Inside our solution, I want to point out that we have two JSON files. As standard, we have the global JSON files, the appsettings.json, and then we have a JSON file for the environment we are targeting. In this case, we have in development environment. If I hit F10, it returns, should return at least an array of two files. Why is it like that? Maybe I have to do also the other one. Oh, we are released. Just a second, because switch the back. Hit F5 again. Back here again. Is recording? Yes. Okay, we are back. Give it F10. You see here we have an array of two elements, and we have the two files which have been encrypted. Then the same happens for the XML files. You just have to pass the search pattern to the file filter pattern, search pattern, star.xml. F10. Here we see that it doesn't keep accepting .xml. If you go to solution, we have just instead one XML file. Take a note that these files have not been encrypted because these files are the solution files in the main root. When you build, they are being copied to the bin debug, bin release directory. So let's open Explorer and move here. We go to bin debug. We should be in net date. Let me see. Yes, 17 March 23. We have three files. Let's open these three with the notepad, and you see that they have been encrypted. All the existing protected tags have been transformed into protected tags. For example, let's see the fully encrypted connection string with just one protected tag, encrypting all the connection string. Instead, in the partially encrypted connection string, you have four protected tags. 1, 2 for the catalog, 1 for the user ID, and 1 for the password. The same happened also to appsettings.json. And the same also happened to the XML files. You can see that in the XML files, we have changed the tokenization. We are using order protect and order protected. I can open the XML file again. Maybe I was too fast. Here we have order protect as encryption tag. And here we have the order protected. Just note about the subkey derivation. Basically, here we have the extended tokenization. This part, which I am highlighting, is optional. Basically, I'm saying you have to encrypt this data after having created a subkey using this text string as a subkey generator. How to create this subkey or to change them is up to the encryption provider. Data Protection API has a document about this. There is about this NuGet package. There is also a detailed article. Initially was on Code Project, and it was then closed, shut down October 2024. Then I made a copy of the article also on my personal homepage on GitHub Pages. But you should be find at least in read-only mode the original article also on Code Project. I will put the links in the video description. And there is inside these articles, they are very detailed and explain everything, explain also how the code works. Not only how to use it. And there is also a link to the Microsoft papers which explain you the concept of subpurpose. So having one encryption key and created derived encryption keys using substrate subpurposes. These substrates are called subpurposes in the Microsoft Direct. Anyway, I want also to highlight that you can encrypt something strange. For example, let me see. You can encrypt the times floating point numbers, so double and float. You can encrypt the single element of an array, but not the whole array. This is just a limitation. And you can encrypt booleans. You can encrypt integrals, either integers, simple integers, or longs, whatever. And you cannot encrypt null. Okay, the only thing you cannot encrypt is the null value. But that would be quite debatable if you want to keep null values. Anyway, let's go back to the test program. Okay, so I've encrypted all the JSON XML files. Now I will encrypt also the environment variables. Basically, it scans all the environment variables. I have created these two. Let me see. Environment, get environment variable. Okay, and also only this one because this is plain text. There is no tokenization, product tokenization here, so it won't be encrypted. So if you hit F10, okay, that's not so nice. Maybe I have to refresh. Let me see. Okay, yes, I have to refresh. I was feeling it wasn't working, but no, there is quite an extensive test on the whole package. There is test, XUnit test, which generates thousands, even 100,000 configuration values. It generates basically plain text values and encrypts also in another key the same value. Then it passes all this encrypted data through the new protected configuration builder in order to allow its decryption. And then at the end, it checks that every plain text key is the same as the encrypted key. If you see here, every key is plain text, environment password, encrypted environment password. Also here, plain text in memory special characters, encrypted in memory special characters. This is just a simple test program, but the XUnit test code generates all this kind of data dynamically for thousands, 100,000 records, and tests that all of them are equal. Also, the values are not only the keys, but also the values are generated randomly using all possible strange characters. So it's very well tested. It should be working almost on every possible use case. Moreover, I did also perform, it is random, all this data is generated randomly. I also performed the XUnit let me see, show Text Explorer. Text Explorer, the X unit, here with the test. And I can see it's great because I'm debugging now, but it's run until failure, which basically executes the test 1000 times. It took around 8 hours for all for every version framework. You can see that the package is available for Net Core, so Net 8 now. It was also Net 6 when it started, and also the old Net framework since Net framework 462. And it also is also Net standard compatible, so it should also work, I think, also on Blazor. So anyway, I want to say that it has been extensively tested. Okay, so now everything has been encrypted. Now we go to the actual code, which is the using the new protected configuration builder. But basically, you pass this class, which the famous class implementing interface, which implements you the encryption provider and the two regex for the tokenization and the string to convert one tokenization to another, and then use the standard methods to create the so-called high configuration root, which is the basically of all Microsoft configuration. If I hit F10 and go to the configuration variable, okay, so let me see. No, wait, just a second. No, I don't like this one. Why? Providers. Okay. So there were also configuration keys, which is the merge of all the keys. One thing maybe not all people knows, in all Net framework, usually basically XML files, and you have just one XML files. In Net Core, usually instead for configuration, multiple configuration sources, and the Net framework and the Net Core was also, it works also on the standard Net framework, performs a merge. So if you define a key, for example, in the command line here, and then later you add another configuration source which defines the key with another value, it will use the last one added. There is also in the article a point to the Microsoft original code, which shows how it works. Basically, you define here a list of providers. When you want now, when you try to fetch a configuration value of one key from this configuration variable, it backtracks all these providers starting from the last one and to see if the key is defined here. If not, it goes up, and the first one it finds, it turns it. In this way, it just performs very cleverly a merge. We are actually merging data. So anyway, you can see you have 6 providers. If you count here, we have 1, 2, 3, 4, 5, and 6. We have the first one, which is the command line. I have renamed it protected because it's implemented my provider. Basically, all the code works by using the principle of composition. So I created standard provider from the Microsoft and apply one composition to one my class, which performs transparent flawlessly decryption. And do this for all kind of providers, because all providers Microsoft must implement one main interface, and basically I implement decryption just using all the methods of all that over that interface. In this way, it should support any configuration sources or configuration provider, and even also not only the existing one, even also the future ones, or any custom one you have been developed. Okay, so we have here the command line, you have the JSON, the two JSON files, one for upsetting, for subsetting development, one for XML files. one for the dictionary and one for the environment variables. Okay, now I'm defining here other dependency injection. Basically, I am creating a strongly binded class to represent all the configuration keys contained in all these configuration sources. If you see this class settings, you have here settings defined .json files. Then we have settings defined in XML file. Then we have settings defined in memory collection. Then we have settings defined in environment variables. Then we have settings defined in command line arguments. And that's it. Then we use also, my code also supports the e-option monitor interface. So it should support the hot reload. So if you example you're executing code and someone, it works just fully, but it is a framework which implements this. It works only for file system providers, so XML files and JSON files. If you happen to overwrite a JSON file which has already been loaded, it performs a callback using file system watcher, and it reloads the file and automatically it decrypts the files and gives you the updated values. I will test also it here. Basically, you define this on-change callback, which is called every time you reload, which is like the configuration source file, XML or JSON files, happens to be modified and this gets reloaded. There is already a debugger break inside, so let's go forward. Okay, first test, it says here, check is that all the values in the upsetting class are attributed to the decryptor with the right value. So we take the upsetting class. Okay, so let me see. Let's go back to JSON files, for example. Let's go back for the correction strings. We have a subclass. We have the 3 keys. Okay, the plain text is the plain text. So it's the same, no problem. The partially encrypted, you can see that it has been decrypted. You can see we have local instance, local second instance. We have secret catalog here. We have secret user here, and we have secret password. And also the fully encrypted connection string. We have server1 / first instance. The initial catalog DB name, SA, and pass, which is, you should never do this, but in development environment it happens a lot. And pass 5678. So this one worked perfectly. Let's see for the other ones. I have, for example, the JSON special characters. JSON special character, this is a plain text, the encrypted JSON special characters. Okay, here they are the same. The code then the code has some instruction to check they are the same. So if everything is wrong, it will crash, but it won't. And the same happened also for the XML file. Let me see. For example, the auto retry delay is it inside the transient fault handling option. So it's here. The full hierarchical model of Microsoft configuration is preserved, so it supports hierarchical files. You see the 0007. The same happened also to the subpurpose is 0007, but the decryption values I will show you are different. We can go immediately again back here. You can see that this one has CFTJALA and Gel A11, let me say that you're the same. No, it would be let me see. I can just be sure. I search this. No, it's just this occurrence here. So I was fear it won't work, but I mean it's almost more than a year that I'm updating it. No, updating it on December for it's 4 months, but anyway, it works. So the same input text 000007 has been encrypted with two different encryption keys, and here is the result. And also the setting is encrypted. I'm not cheating. Okay. I mean, we can check manually, but there are assumptions. I want to spend too much time. Uh, Here follows the assertion. So basically, I'm checking the plain text value is the same as an encrypted one, and also this also on the connection strings, also on nullables, doubles, ints, booleans, on elements of array, also this and this. So all the assertions are fine. Now I'm testing also the hot reload. So what I'm doing a loop for 5 times. Inside this loop, basically, I'm doing an accurate way of updating the the JSON dot development the status dot development dot JSON file. We can go here, F5. Basically, I perform a regex replace. I tell him, with this code, I basically take the int configuration key inside the settings development JSON. So this one, which is free, and say to replace it with a random value, and which gets encrypted. Let's see. It should have okay. The file is changed. Reload. Boom. The int has now been encrypted. Let's go back and do a slip. Boom. The callback, which I've supposedly sent before, has been called, and we can see that in the upsetting reloaded parameters, which is passed as input to the callback. If you go back, we have the int, which has 900,000 930 795. I'm not so good at reading numbers in English, but you should say 930,795, if I remember correctly. It has been updated, and you have immediately has performed a callback and gives you all the new value already decrypted. Then I hit F5. It goes again in the loop. Okay, now we go back in the loop after the sleep. We can see that if we call option monitor current value, here now in app settings we have still the old value. It's free, yes, but if you reassign with the current value, boom, you get a new one. Usually you should do this inside the callback, but I'm doing here just to show that everything works. I'm also logging. Okay, this is another time, F10, F10. Okay, this is an issue, sorry, because it is also stated in the, sorry. It was also stated on the Microsoft documentation. The file system watcher can be called multiple times. This happens for a lot of reasons. Usually antivirus software which performs intercepts the try that you are writing the file, it analyzes it. I mean, if I open the link, there is a link. There is also the bug, and but there was also here remarks on the file system watcher. You can see that the common file system operation might rise more than one event. For example, when moving, or for example, since some complex application, antivirus software might cause additional file system events. So these called are called, but they are not sure to be called just once. They could be called multiple times with the same value. Anyway, we have updated again the value with another value. You can see here that the files gets reloaded. The old value was 930,795. I hit F5 again. We should break inside the callback. Okay, now in appsettings reloaded, we have a new value, 343,912. Instead, we'll see that in the appsettings here, there's still the old value. F10, it gets updated to new one. So, an active way of testing this one, this is the only part that is not tested in the unit test, but it's a feature of not framework, but I never used. Never used to update dynamically the configuration settings. I think it's also even dangerous. But anyway, you know, it's supported, and if you need it, you have it. So the test format now has here. It performs 5 times this test, and then the test ends. So this is a general overview of this package. The article on the project covers almost all the points in more details, and moreover, it explains also the how can you say all the implementation, the code implementation, how it works. To give an idea, basically, the protected configuration builder implements the standard configuration builder of the net framework. And basically, in the net framework, all the configuration sources which you add through the add method in the program here, add the command line JSON files, are converted, all of them, into a dictionary of strings. So all the data, whether it's Boolean, whether it's floating point, whether it's converted to a dictionary of strings. And this dictionary then gets loaded by the various configuration providers, and the actual class performing the decryption is the basically when you add the configuration source, you load the data from the source, and then you create a provider which loads the data loaded from the source into the dictionary. The configuration provider performing the decoding is this one. It basically implementing a standard interface, the configuration provider. It has a method which is the correct set keys, which is the core logic of decryption of all configuration values, and this is called whenever you load the configuration source. So basically, what it does when you are here, see in the program, you hit add command line, it executes all which has to be executed by the command line configuration source, a command line configuration provider. Then the code stops here. It calls the provider load, and then after the load, it calls the encryption keys. So it's not so complex from the concept viewpoint, but it was difficult to plumble with the net framework classes and to be as much as possible stick to the standard net framework providers. The only interesting idea is that the net framework provider do not have a property inside this e-configuration provider interface. Okay, we have, for example, a method to get a value, to set a value, to get a load token, to load the data, but we are not a method to enumerate all the configuration keys loaded. And so it was difficult to me to access all the configuration keys and to decrypt them, to cycle for them in order to decrypt them. I did quite a hack because I used this code, this method, this get child keys, which gives you, according to a level, all the child keys. And in the initial code, I called it recursively in order to enumerate all the keys. Is this part of code? This code works on all providers implementing a configuration provider interface, and it will also works also for the future ones, but it has a limit, which is it is not so fast. So I implemented also a speed up this by using by noticing that all the e-configuration provider, the actual implementation, have dictionary properties dictionary properties which can be used to speed up the access to the data with configuration keys, and also to enumerate all the configuration keys. And basically the code checks. We have dynamically with the reflection, but just once. If we have the this dictionary defined in the configuration the class implementing the configuration provider, okay, let's use it, and it is you get use speed up. I've written a comment here 3,000 times. And otherwise, if this property, this dictionary property is not present, use the old method, which is compatible with all providers, because it uses only the method provider in the configuration provider interface, but this is slower. And anyway, in the article, everything is very well documented, explained, so I won't waste any more of your time. If you enjoyed this video and you think that this package is useful, let me know. By the way, the package has been released under the Mighty license, so it's free for personal use, for commercial use. The only you can extend it, you can override, do whatever you want. The only constraint is that my name, the author's name, Federico Di Marco, is stated in the copyright together with yours if you send it, but you have to be the first one. So I hope you enjoyed this video, and I hope you find my package useful. Thank you for your time.